All right, today we're going to tackle one of the biggest challenges in the data world. How do you build a single source of truth for your entire organization? And we're going to see how Google's BigQuery is making that a reality with a powerful concept called the lakehouse. Does this sound familiar? I bet it does. It's the classic data headache, right? Your business intelligence teams, they're begging for clean, structured data they can put on a dashboard. But your data scientists, they need the total freedom to dig into raw, messy, unstructured files. It always feels like you have to pick one side, and no matter what you do, it just creates more chaos. For years, this was the choice we were given. The industry basically gave us two options, pitting the super rigid data warehouse against the super flexible data lake. So on one hand, you have the data warehouse. Think of it like a pristine, perfectly organized library. It's fantastic for BI because everything is exactly where it should be, but man, is it inflexible. Then the data lake came along, and it promised total flexibility. You could just dump any kind of data you wanted into it. The problem? That freedom often led to a messy, chaotic data swamp, where finding any real insight was nearly impossible. But what if you didn't have to choose? What if you could get the best of both? Well, this is exactly where the modern solution comes in. It's called the data lakehouse. So what is a lakehouse, really? You can think of it as a hybrid architecture. It's designed to give you the best of both worlds. You get the massive, flexible, low-cost storage of a data lake, but with the powerful structure, governance, and performance of a data warehouse all in one system. And the benefits here are just huge. For starters, you're creating a single source of truth, which immediately cuts down on all that costly and confusing data duplication. But the real win, the absolute game changer, you finally have one single platform where your BI analyst and your data scientists can work together on the exact same data. No more silos. And look, this isn't just some abstract theory anymore. The engine that's making this modern lakehouse a practical reality right now is Google's BigQuery. So what's the magic behind BigQuery? How does it pull this off? Well, it's all built on a really revolutionary idea. Instead of going through the slow, painful process of moving all your data into a warehouse, you just query the data exactly where it already lives. BigQuery basically has two powerful tricks up its sleeve to make this happen. Let's break them down. First up, external tables. And what's really cool about this is just how simple it is. Your raw files, your CSVs, your Parquet files, your JSON, they can all live in cheap and easy Google Cloud storage. Then inside BigQuery, you create what's basically just a pointer table. It's a tiny little object that just points to that data. And bam, just like that, you can start running standard SQL queries on those files as if they were sitting inside BigQuery all along. No copying, no ETL, no delay. And this is the part that changes everything. You can forget about waiting hours or even days for those slow, expensive data copying jobs to finish. You can get insights from your data instantly. The second mechanism, federated queries, takes this idea even further. Just imagine this. From your BigQuery interface, you can reach out and query a live operational database, like your production Postgres or MySQL database, in real time. Again, zero data movement required. It's all about creating one single unified view of your data, no matter where it happens to be stored. So being able to access the data is one thing, but how do you make sure your queries are actually fast? Especially when you're dealing with terabytes or even petabytes of information, this is where we get into the secret sauce for performance. The two key techniques you need to know are partitioning and clustering. And honestly, the best way to think about this is with a library analogy. Partitioning is like organizing the entire library by publication year. So if you only need books from 2023, you can just ignore all the other aisles completely, which saves a ton of time. Now, clustering is like organizing the books within that 2023 aisle by the author's last name. It helps you zero in on the exact book you need even faster. Without these optimizations, running a query is like telling a librarian to go find one specific book by searching every single shelf in the entire library. It's going to be slow, it's going to be super inefficient, and it's going to cost you a lot in time and effort. But with partitioning and clustering, it's a completely different story. Now you can tell the librarian, hey, go to the 2023 aisle, look for the shelf marked S for the author's last name, and just grab the book. The result is a massive reduction in the amount of data your query has to scan, which means you get blazing fast answers and much lower costs. So let's put all of these pieces together now. what does a modern data flow actually look like when you build it on a BigQuery lakehouse? Just picture this for a second. Your curated raw data lands in cloud storage. At the same time, your live operational databases are right there, ready to be queried. BigQuery sits right in the middle of all of it, giving you that single unified view with absolutely no data movement. Now your BI tools can connect and get a complete real-time picture of the business, and your data science teams can finally train their models on the entire data set. It's all right there. Okay, so you might be thinking, this is great, but how do I decide which approach to use for which type of data? Well, let's make it super practical. Think of this next part as your architect's cheat sheet. Here's how to use this guide. If you've got data sitting in cloud storage that only gets updated every once in a while, use an external table. It's perfect for that. For live operational data that you need to query frequently, a federated query is your best bet. If you have data streaming in continuously, that should go directly into a native BigQuery table. And finally, for your core process data sets, the ones everyone is querying all the time, always use a partitioned and clustered native table to get the absolute best performance. At the end of the day, what the BigQuery lakehouse does is it breaks down the walls that have kept your data siloed for years. It gives you a single, unified platform for every single type of analysis. So the final question I want to leave you with is this. Now that those barriers are gone, what are the truly transformative business questions that you and your team will finally be able to answer?